what changed. The first implementation is the standard matrix multiplication that most people write. It works, but it isn't cache friendly. So the CPU spends a lot of time waiting for data to access memory. Like it took around 43 seconds. Let me show you the code behind it. It's like we have 2048 rows, and in Y matrix we have 3500 columns. In this, it is the normal matrix multiplication code every developer has written once in his life. We traverse via X rows, then Y columns, and then last X columns, and accumulate the multiplication in value and assign it to the resultant matrix. The problem in this approach is we travel X row wise and Y column wise. Now the problem is the CPU reads a chunk of bytes. So in case of X, it's always a cache hit. And in case of Y, if it read this, it's always a cache miss. So the time is more consumed. So to optimize this, made a little change in my code, which led to only 8 seconds. Now the change that I made, let me show you the change in code. I switched the matrix multiplication for in the second loop, I made it to X columns, and in the third loops, Y columns. Only the prerequisite is we should prefill the resultant matrix with zeros. And in this implementation, I used this approach like take the first element of X, multiply it with first element of Y, and accumulate the result in the resultant Z matrix. Similarly, repeat the process for all the Y columns. This is the third loop. Now the third loop ends. Now in the second loop, we move X columns. So with this approach, I reached a time second of 8 seconds. And then I checked my CPU has 12 cores, and then I divided the work among all the cores to work parallelly and reached a time of 2 seconds. Let me show you the code for this. Now, why I did this? Imagine you are training a machine learning model which takes around 1 month to train on a cloud. But with this optimization, it saves a lot of time and money. I use this OpenMP library to divide the task parallelly among threads. Thank you.